Hello, ladies and gentlemen. Today we're going to talk about a review topic. We're going to talk about slope and the relationships it has with graphing. So you're going to need a calculator, something to write with, and you have to have something to write your notes on. So the learning topics we're going to talk about, rediscuss today, are going to be finding the slope of a line, using the slope to determine if lines are parallel or perpendicular, and then graphing linear equations. So first off, let's talk about what slope is. Now this shouldn't be a new topic. When you think about slope, I have this picture of mountains in here because the slope is defined as the steepness or incline of a line or road. So when we're trying to find slope, if we're looking on a graph, a lot of us would probably remember the phrase rise over run. And that's what we use to figure out slope when we're given a graph, when we're given a line. But when we're not given a line, when we're maybe just given 2 points in order to find the slope, since we are doing rise over run, it's just the difference in y's over the difference in x's. So that would be your slope formula. Again, both of these would probably be good to get written down in your notes. Shouldn't be something brand new to us, but again, revisiting it so that way we are comfortable moving forward. So, and lastly, when we talk about slope, we have this form when we have slope-intercept form. So slope-intercept form is y equals mx plus b, and this equation is super important in your math careers. So remembering what slope-intercept form actually stands for and what all those letters in slope-intercept form also stand for. So the m in y equals mx plus b would be my slope, and the b is my y-intercept, being where that line is going to cross the y-axis. All right, so for starters here, this first example we're going to talk about, we need to find the slope of this red line. So I would suggest maybe finding 2 points that cross perfectly, and then from there doing rise over run. So the first point I think crosses nicely would be here. And now if I try to find another one, the next one it looks like I'm going to find it's up here. So now in order to find the slope, I need to do rise over run. So if I rise, we go up 1, 2, 3. So if I were to do slope equals rise over run, my rise was 3. Now how many am I running? 1, 2, 3, 4, 5. So then I would look at this fraction and see if I could simplify it at all, but it looks like this fraction can't be simplified. So my slope of the red line would be 3 over 5. All right, so now let's talk about some slope facts that are super important for what we are learning today. So the first slope fact we want to talk about is positive versus negative falling. So if we have a positive slope, that is going to rise to the right. It's going to grow as we read from left to right. It's going to get higher. A negative slope is going to fall to the right. So as we go from left to right on the graph, it's going to fall down. It's going to go down. Now, two really important things that are good to memorize. When we talk about slope of 0, so there's no slope, that's going to be your constant line. That's going to be a horizontal line. And then when we're finding slopes like this, the slope of a 0 line would be an example in parentheses here. Get that jotted down. When 0 is on top of my fraction, we're going to have that horizontal line. My slope is going to be 0. It's going to be a steady, even horizontal line. But when 0 is in the denominator, we can't divide by 0, so that's going to be an undefined slope. So your undefined slope is when we have a straight up and down line. So that's going to be your vertical line. So the difference between a slope of 0 when it's growing at a constant rate, it's not growing at all, it's just level, versus an undefined slope because it's undefined because we cannot divide by 0. So understanding the difference there is super important. All right, so in our next example here, we're going to start talking about the comparison between parallel versus perpendicular lines and how we compare their slopes. So this example wants us to find the slope of each line, and from there we're going to determine which lines would be parallel. So again, we have to remember that the slope formula is m equals rise over run. So if we look here, we have 3 different lines. I'm going to focus on line A first. So since I'm rising, this time my rise is actually going down 1 first. So we represent that with a -1 over, and it looks like it's running 1, 2, 3, 4. So -1 over 4. Now when I look at the next line, line B, we're going to do the same thing. So we're going to first off start by looking at my rise. Again, it looks like my rise goes down. So we'll represent that with a -1. And if we talk about the run, we'll go 1, 2, 3. So my run was 3. Lastly, if we look at this last example, line C, again, we're going to go down 1. So m equals -1 over running 1, 2, 3. So -1 over 3. Now, just looking at the graph at the beginning, I could have told you that A and B look like eventually they're going to touch. And the definition of parallel means that the lines are never, ever going to intersect. So when I look at that, I could say, okay, well, A and B are never going to intersect. But then I look at B and C, and it looks like maybe those might be parallel. In order to prove them parallel, the definition of parallel is two lines with the same exact slope. So the two lines right here that would be parallel would be B and C. And a definition you're going to want to get jotted down in your notes then is when we talk about parallel lines have to have same slopes. So whenever we're talking about comparing the two lines, if they have the same slope, we can assume that they would be parallel. All right, for this next example then, here we're presented a little bit different type of question. So here I have two lines, each presented with 2 points. So now my goal is to figure out the slope of each line. So here's where we would use m equals y2 minus y1 over x2 minus x1. Now I can pick and say, okay, this is going to be x1, y1. This is going to be x2, y2. Or I can say I'm going to go left to right, right to left, however I want to do that, and just plug in my numbers from there. So y2, with the way I labeled it, would be 3, subtract y1, which would be 6, over x2 then would be 6, and x1 would be 2. So what that looks like then, if I were to simplify this, 3 minus 6 would be a -3, 6 minus 2 would be 4. So the slope of the first line is going to be -3 over 4. Now, if I were to do the same concept for line 2, so m equals y2 minus y1 over x2 minus x1. Again, if I want to label these x1, y1, x2, y2, labeling them xy because every ordered pair is in terms of x and y. Now, if I look at y2, y2 is 7, y1 would be 3, so 7 minus 3 over x2 is 4 minus x1, which would be 1. So 7 minus 3 would give me a 4 on top, and 4 minus 1 would give me a 3 on bottom. Now, if I were to look at these two slopes off the bat, I might not know how they compare, so let's see if we could graph them. If I graph both of these lines, they would look like this. And if you notice, the point of intersection looks maybe a little bit familiar, but the point of intersection looks like it maybe forms right angles. And I'm going to tell you that they actually do form right angles. So when we're looking at these two slopes and how they compare, these two lines are going to be perpendicular, but what do the slopes have in common? So perpendicular lines are going to be lines that have opposite reciprocal slopes. So opposite reciprocal. So opposite means it's going to be the different sign. And reciprocal is going to mean that I flip the fraction. So again, parallel lines are going to have same slopes. Perpendicular lines are going to have opposite reciprocal slopes. All right, here we have to determine whether the lines are parallel or perpendicular, or even if they are neither. So if we do our slope, because remember we have to use those rules, parallel lines have the same slope, opposite or perpendicular lines have opposite reciprocal slopes. So let's just look at what the two slopes would give us. So if I'm focusing on line 1, I want to take y2 minus y1 over x2 minus x1. Again, I'm looking at line 1 here. So if I need to label x1, y1, x2, y2, then I can just plug it into my formula right from there. So y2 is going to be 1 minus y1 would be 4 over x2 would be 3 minus x2 would be a -3. So now it's important that I'm putting that -3 there in parentheses, because if I subtract a negative, then these are going to end up turning into positives. So I'm going to get negative 3 over 6, which then simplifies to a negative 1 over 2. So if I do this similar process with line 2, y2 minus y1 over x2 minus x1. Again, if I go label x1, y1, x2, y2, I get negative 7 minus 1 over 2 minus 6. So that's going to be a negative 8 over negative 4. If we were to simplify that, we would get a 2 over 1. Now, when you look at comparing these two slopes, first off, it looks like they have different signs. So they have an opposite sign. And it looks like 1 over 2 is the reciprocal of 2 over 1. So if I have opposite reciprocal, this would tell me that these two lines would be perpendicular. So I would just have to write perpendicular. The last thing we're going to review today is how we graph a line. So again, this goes back to getting that into your slope-intercept form. And if we forgot what slope-intercept form is, it's already in our notes, but y should equal mx plus b. So the goal here, if you notice, this isn't already in slope-intercept form, so we want to get it into slope-intercept form. So in order to get it into slope-intercept form, it looks like that y needs to be alone. So this equation here, I'm going to solve for y. So I'm going to subtract 2x from both sides. I'm going to be left with 3y equals negative 2x plus 12. Now you're probably wondering why I put the negative 2 first. I put the negative 2 first because here in my slope-intercept form, mx comes before the number. So I'm going to keep it in slope-intercept form by keeping that x coming first. Now still we're not done yet because I have not solved for y. So in order to solve for y, I have to divide both sides by 3. That means I have to divide everything on both sides by 3. On the left-hand side, I'm going to get y. Now 3 doesn't divide into 2 evenly, so I'm going to leave it as a negative 2 over 3x. But 12 divided by 3 would be 4. So now here's the equation that I am going to graph over on the right-hand side. So again, if you looked into your notes, the m stands for your slope, and the b is my y-intercept. So y-intercept means where it's going to cross the y-axis. So here, when I have a positive 4, that means I'm going to go on my y-axis, which is the one going up and down. And I'm going to go up to a positive 4, and I'm just going to plot a point right there. From there, then I'm going to use my slope, which is a negative 2 over 3, which is rise over run again. So if I do negative 2 over 3, the negative tells me that I need to go down. My rise is going to go down 1, 2. So now I'm at 2 on my y-axis. And the 3, since it's positive, is going to run to the right 3. So if I were to do that, I would get these points. Now what I'm going to do to make sure I can make a straight line, I'm going to keep using my slope until I get to the edge of the graph. So again, I'm going to go down 2. I'm going to run 3. So here I'm getting close to the edge of the graph. I'm going to do it, and then I can connect my points to get a line. So here would be the line of y equals negative 2/3 x plus 4. If you have any questions, make sure you jot those down. Again, this shouldn't be something that's super new, but you might have struggled with it in Algebra 1, so we need just to make sure that we're ready for this going forward.